Alright everybody, let's take a look at question 3. Question 3 deals with distance and midpoint mostly. Makes this maybe a little more complicated as that it's in 3 dimensions. Not particularly more complicated, just a little alteration to our formula, but maybe just a little. Okay, let's read the question and see what we can do. An inclined railway travels along a straight track on a steep hill as shown in the diagram. The locations of the stations on the railway can be described by the coordinates in reference to the x, y, and z axes, where the x and y axes are the horizontal plane and the z axis is the vertical. The ground level station A has coordinates 140, 150, 0, and station B, located near the top of the hill, has coordinates 25, 250. All coordinates are given in meters. First question 3a asks us to find the distance between points A and B. This is a fairly straightforward question actually. We can use our distance formula, and this is in your formula booklet. And the distance formula is going to be the average of the x, or sorry, not the average, the distance between the x direction. So this is x2 minus x1, we want to square that, plus y2 minus y1, we want to square that. And then, since we're dealing in 3 dimensions, it's z2 minus z1 squared. And actually really doesn't matter whether you mix up x1 or x2. Since you're squaring it, it's just going to come out positive anyways. It's like the absolute value, a magnitude. Alright, let's go ahead and put in some of those values. X2, x1, so this would be 140 minus 20 squared. Y2 and Y1, I'm using these examples, I'll just label them real quick. X1, Y1, Z1, and I won't do anything more complicated with this. Y2 and Z2. Alright, Y2, oh, I think I actually did it the other way around. Y1, that's fine, that's fine, that's fine. As long as we're consistent, this is the idea. Alright, 15 minus 5 squared plus Z2 minus Z1, 0 minus 250 squared. Okay, and this I think I'm going to need the calculator for. This is 120 squared plus 10 squared plus 250 squared. I'm just going to get my calculator out. 120 squared plus 10 squared plus 250 squared. This is going to give us, what is it? Square root of 77000. And taking the square root of that business is going to give us 277.5 meters. So what do we do with the IB in there, 3 sig figs? 2.77, it's actually 2.7748. So what do we do? Rounding it to 3 significant figures, round it to 277. This is less than 5. 277 meters. Okay, and that would be the end of part A. Find the coordinates of station M. I think we can probably fit this in actually in this window, so let's go ahead and do that. B, find the coordinates of station M. They tell us that M is to be built halfway between A and B. Halfway between, that sounds like the midpoint, and that's exactly what we do. So the midpoint, remember, is equal to, well, the average of the x's. That's a little messy. Average of the x's, the average of the y's, and the average of the z's. Z coordinate plane, or the z coordinates rather. X1 plus x2, this is going to be 140 plus 20 over 2. Average of the y's is going to be 15 plus 5 over 2, and the z is going to be 0 plus 250 over 2. And I think this one should be okay. 140 plus 20 is 160. This is going to be 80. 160 over 2. 15 plus 5 is 20. 20 over 2 is 10. And 250 over 2 is going to be 125, I believe. Yeah, that's correct. Okay, I think that should do it. This is our midpoint. I guess we can circle in our answers, box them in. Is there enough space for C? Write down the height of station M in meters above the ground. So this is station M. This is station M. This is our midpoint station, I guess. station M. And it equals 80, 10, 125. They told us earlier that the x and y axes are the horizontal plane and the z axis is the vertical. So this is our z axis right here, and it goes up and down. And this is of course x, this is y, and this is z. So this final coordinate is our z. If we're looking at this right here, this x, y, z, x, y, and z, we're looking at this 125. So write down the height of the station, m in meters, c, height of the station is 125 meters. That would be the height. We could even write h equals 125, I guess, to be, I don't know, a little more specific. H is equal to 125 meters. That's the height above the ground. Okay, so that wasn't too bad. Let's go on to the next question.